In this video, we're going to talk about tree structure in Grasshopper. To start with, let's draw a line. We need to feed 2 points to this line. Let's use 0, 0, 0 as the first point and 10, 0, 0 as the second point. Now we have a line between the 2 points, which is here, shown in green on the screen. Let's divide the line using divide curve component. By default, it's dividing it into 10 segments, and you can see that there are 11 points in the output P. And if I plug this into a point data holder, and you can see that this is a list structure because you can see solid double line. When you have one item, the wire will be a solid single line. Now to look at the tree structure, let's make a copy of this line before we go further. Let's move the line along y-axis and let's make a couple of the lines. So use series. Once you plug in, I can create 10 lines along y-axis because default value for this count is 10. Let's create 5 of them. So I have 5 lines on the screen. And now if I divide all of the 5 lines using the divide curve, you can see that I just divided all of the lines into 11 points each, 10 segments. If I hover my mouse over the P output now, you can see that the structure has changed. I have a total of 55 points under 5 different branches. To further investigate the structure of it, let's hide all of these batteries and then use a component called param viewer to investigate what the parameter is. There are 5 branches. Under each branch, there are 11 points. Right click on this component, use a draw tree. You can see that I have one main branch and index that 0, 0. And under that main branch, I have 5 sub branches. And the indices are 0, 0, 0, 0, 0, 1, 0, 0, 2, and so on. And under each of the sub branch, there are 11 points for each of the branches, so total 55 points. So when it's a tree structure, you can see the graphic style of the wire has changed. For a list structure, it is a solid double line. For tree structure, it is dashed double line. Now, if you right click on the param viewer and check that preview, you can actually investigate the index of each point. You can see that the first one is the index of the branch is 0, 0, 0, and this indicates the index of the point. So 0 and 1, 2, 3, 4, 5, and so on. So you can see that the index for the branch maintains the same 0, 0, 0, and 0, 0, 0, and so on. But the index of the points goes from 0 all the way to 10 over here. And for the next row, you can see the index of branch is 0, 0, 1, 0, 0, 1, like that. And the index for the point is 0, 1, 2, 3, 4. And it goes on as you go above the branches. So what if we use point list to investigate index of the points further? Let's make it slightly larger so you can see the indices of the points. You can see that for each row of points, you have index 0, 1, 2, 3, and so on, all the way to 10. For the next row or next branch, you have a 0, 1, 2, 3, 4, all of them like that. So if I use list item to select specific index, by default, the index is 0. So you can see that all of the points with index 0 is selected, which is the first column. And if I change that to index 2, then it's going to select third points from the tree. Sometimes when you want to further investigate each branch, you can use explode tree component, or oftentimes I'll rather search bang, and this is going to be a shortcut for the explode tree component. So now you can see that I have 2 branches, the first 2 branches selected as shown in green on my Rhino screen. Because there are 5 branches and it's only showing 2 of them, you can see the color of the battery is in orange and there's a bubble. When you click on the bubble, it says that the tree contains more branches than the component has output parameters. So meaning that I only have 2 here, but there are more. So that's what the warning is about. To show more branches, you can zoom into the component, click on the plus sign, or you can just right click on it, use the match output. This is going to bring out all of the branches, which is 5 in this case. Each of the branches, if I use the point data holder, you can see the first one is the first branch, and the second one is the second branch, and third branch, and so on like that. Sometimes we need to transpose the index of the points. In Grasshopper, we call that flip matrix. So before you flip the matrix, you can see that the index counts from 0, 1 to 3 along the rows. But if we flip the matrix, the points are indexed vertically, 0, 1, 2, 3, 4, along the vertical lines. If I hide all of these, and then assuming I'm drawing lines across all the points using the polyline component, before flipping the matrix, this polyline component draws lines horizontally because the index is 0, 1, 2, 3, 4, like that, going horizontally. After we flip the matrix, you'll see that the lines are vertical because after we flip the matrix, the index of the points are 0, 1, 2, 3, 4, and ranging upwards.